Hello and welcome to the video. Before we get started, if you'd like to provide input on future content and get our weekly newsletter, click on our survey. The link will be below. We also have a report on Ethereum 2, along with a bonus report on why you should learn Solidity now. Again, the link will be below. Now on to the video, and thank you. Okay. So today we're going to continue on with this series, and I'd like to get some feedback if people are interested in this, or want me to discuss other things. I know that someone mentioned Solana. I think Solana to me a few weeks ago, and I do want to get to that. That's probably next project at bat. But I would like to go through this documentation because I found that there's a lot here, and sometimes it can be a little confusing. So anyway, let's get started. Today we're going to talk about values and evaluation. So once a Motoko expression receives control and starts evaluating, it ends up with a reduced value. Now, it could pass, as they talk about here, to sub-expressions, subroutines, before it gives up control of the main stack. They call it the ambient control stack. Think about ambient temperature, like the temperature in the room, the stack, the overall stack is the way I interpret it. It's possible that you can have non-termination, particularly in recursive functions and in what they call imperative flow control, which we'll talk about later. That's very interesting to me because one of the things you learn about recursive functions is that you have to, they have to recurse. They have to stop eventually. You have some stop state, but apparently here not necessarily. These examples we've looked at that they provided have been focused on what they call natural numbers, and so that's like what you think of, like things you can have physically. You can have physically 0 apples, 1 apple, 2 apple. And they talk about the primitive values, and there are only 4. Boolean, which is true or false. Integers, which are bounded or unbounded, and we'll get into what unbounded means. So that could be negative anything to positive anything. Natural numbers, 0, 1, 2, again, bounded and unbounded, and text. Now, unbounded means that you're not going to get overflow. It'll just grow to what it needs in terms of width, in terms of how many bits it needs, how many bytes it needs in order to handle whatever numbers passed in. Now, you have bounded types, in which case you can have an overflow and you're going to get an error. Whoop, I hit the wrong button here. Let's see, it's right here. All right, so there are no unchecked or uncaught overflows, except they're talking about certain situations that will be discussed later. And not a non-primitive values. So you have number types, the typical types if you're used to programming: tuples, arrays, objects, which fields and methods, so they are objects in that sense. Variants, and we're going to get more in detail on what these things are. Function, values, async. We talked about async being promises, an error, carry the payload of exception and system failures. So if you do try catches in a lot of popular languages, and you'll get, like in Java, such and such exception E, and when you get E when you get an error, you can do, call a bunch of methods on E, like E dot print stack, or where print everything out, things of that nature. So we're going to get more into these. Again, they have the language quick reference. Let me just show you that. And this is where you can look up anything. So integers, digit, so on. Floats, they do have floats. And characters, different things that go beyond what we were talking about, that they talk about here. And they have that whole reference. Now the other thing to talk about is the void type. If they, in Motoko, we think of them as a unit type written in the empty brackets there. It's a unit value. There's nothing. So if you have a method with a void, that's a void method, it's not going to return anything. It can do stuff in it, but it's not going to return a value. So it could be to print something out. It can be to, if maybe you change the value of a pointer. Maybe you set a bunch of values in the method, in the class, etc. And here are natural numbers. Again, one of the interesting things about this language is that you can have them with no limits. So you don't have to say, well, do I need an int, a double? No, it's not double. Int. I guess you could say double, no, it's int, it's long. The doubles are, have the decimal point there, but int, long, you don't have to worry about that here. Do not have to worry about that. Now let's look at this. So what would x be? They say it's 45. So 38 and 42, it would be 80. Program value weights to 40. Oh, I see. 36 divided by 12 is 3. I see what, yeah. So you got it does this first, and then this, and then it does the addition. Now type soundness, again, that goes into being strongly typed. It knows what type it should be, and it catches it ahead of time. It enforces it. You can't get some weird error because you pass an integer into a text. It'll catch that. The whole idea is it's supposed to catch that. The system will enforce it. It's not going to let you do that. So let's see. This short program here, let x net, which is natural, equals 1. The compiler will say that it knows that 1 has type nat, and x is the same type. And so it inferred nat. You don't even need nat here. It doesn't mean any. It's. I would say it's more of a self-documenting feature to tell you. Now in this case, it's pretty obvious. these two are equivalent, because it just knows that if you have the number 1, it's just going to say, well, it's a natural number. Now, sometimes maybe there are cases where you want to make sure it knows it's the type that you say it is. And for it to accept it, everything has to be consistent. The annotations have to be consistent with the values, and if you don't have like here's an example right here. So you're telling me X is a text, but then you're giving me 1 plus 1. Well, obviously that's a net. So if you have a conflict, it'll give you an error. And I've seen that playing with stuff. Now, the next part here, the final part of tonight's lesson, is errors in messages. So what they give you, if you're not using a debugger where you can actually say stop here, what it will do is give you some tools. And you know, sometimes you just, depending on what situation you're working in, this can be very handy. And I think every programmer finds time they have to, they need to use it. Very often, if you're trying to debug something that's running on a web server, for example, it's maybe easier to just log stuff and then look at the log, and then you can narrow stuff down to see how far your program got. I've been in cases where I couldn't use a debugger, and this stuff is a lifesaver. So the first one is here. First of all, you have to import this library here, which is the debug library, and it gives you you can print, and so it can print out any text. The print, so let's see, functions such as impure. Okay. So the side effect on print is emitting output, modifying state. Well, instead of result has the side effect, and that is printing it out to the terminal. I don't know if I'd think of that as a side effect, but I guess it is. So it allows you to transform what you have into something a human can read. Debug, show, lets you do even more. So here's a good example. So this is very helpful. This is very helpful. So suppose you large class. So what it does is it takes these things. You got your text, your net, and a text, and you can print it out and in print, because print, remember, has to be text, and this will convert it to text. So that's very valuable if you're trying to check output that isn't text, because obviously a lot of times that won't be the case. Now here's a very interesting thing. Now this is something you might use while you are developing something. It's accommodating incomplete code. So maybe you have something that's not quite done. It allows you to handle that. And they have 3 things: XXX, NYI, and unreachable from the Prelude library. Interesting. So this is a missing expression. And the result will always type check and will always trap at runtime. Now let's say you have longer time, like not yet implemented. That's what NYI stands for. And it's a similar function. And then some code will never be filled because it will never be evaluated. To document a code path as possibly illogical and unreachable, you can use this. Now that's interesting because I don't know, certainly in Java, if you have code that it can't reach, it's going to complain generally at the compile time, or in the at the very least, it usually complains in the one of the traditional typical editors. Assertions, and this is the final thing. Assertions allow you to check, let's see, typically assertions are, if something happens, you can tell it to, whether it fails or succeeds. So you would use these things in this case. So each form, okay, so a simple wrapper, it's an assert primitive. So this just halts if it executes that code. So let's say you have a failure case that if this happens, I want to stop. Let's say I check a value and the value is supposed to be a certain thing, and if that's not right, then I want to stop and trap it. So here's the assert primitive, and we're going to get more into that later on. That's in a later chapter, but this is another way of handling errors, and we've seen stuff like that when we were working in some of the other languages. So I think Solidity has a similar way of checking something and saying if it's right, if it's no good, then end, halt, end. And I suspect this probably is the assert primitive. Let's just have a quick look at that. See how they use it here. Okay, assert. So assert expression. So assert trap when it's false, the value empty when it's true, or trap when it's false. So it's a typical assert that you might also see in some of the unit testing languages. If you've ever done, let's see, if you've ever done JUnit, things of that nature, you use asserts in there all the time. So what have we learned tonight? We have learned that there are, for one thing, some very interesting features in this language. The fact that it can handle numbers with unbounded and just provide enough space. The fact that, let's see, how well typed it is. The fact that it can kind of make logical assumptions about the type and make sure everything is consistent, even if you don't tell it. And that it has some very nice features in terms of doing your debugging. It has ways to handle situations when a code is a work in progress and you want to handle either stuff that you're not going to do for some time, or maybe it's just a method that you need to implement and you haven't gotten to yet. You want to note that something is unreachable. Now, I don't know, if someone would ever want to do something, have an unreachable path. I mean, if you have an unreachable path, then you probably want to get rid of it. At least my thinking is you'd want to get rid of it, but I can see, or maybe you're not 100% sure. and this would handle that. Or maybe you're planning on changing something that would make it reachable. So anyway, hopefully this has been helpful. And again, let me, I'd like to know what you guys think in terms of where we're going. Hopefully you're enjoying this series. And I want to, if there's interest there, I want to go through this whole thing, and at the end, we should understand how this language works. Right now, we're going through some basic stuff. Tomorrow, we're going to start getting into the more details, and I think that's going to be a bit more interesting. And if there is less interest, what I may do is do some other things, and then throw more of this in, so that I can at least get a complete series in there for those who are interested. Anyway, again, hopefully this has been helpful. If it has, please subscribe, please give a like, please ring the bell to get further episodes, and please share this with your friends who may be interested. Again, I have some survey, and I have some reports that are available, and that's listed down below. And I mentioned that also at the very beginning, kind of as an intro. Anyway, again, thank you for watching, and I will speak to you next time.